Hello everyone. This video is on section 9.6 part 1 titled Parabolas and Their Properties. In this video I'm going to be going over the Knewton Alta homework, or a version of the Knewton Alta homework assignment for section 9.6 part 1. Please understand that the questions I'm seeing in this video may not be the same questions that you see when you're working on the assignment yourself. But the objectives are the same, the types of questions would be similar, and how you go about doing them should be similar to how I do them. So I'm hoping that watching me work on these here help you in some way when working on the assignment on your own. Alright, so here's the assignment page. Now you will not see the words preview of, you're just going to see section 9.6 part 1, right, the title of the assignment. And you have your mastery bar telling you how far along you've gotten. The objectives, and it looks like there are 3 objectives in this assignment. And beneath each current objective there's a question related to that objective. And at the bottom of each question you should be seeing a feedback button, so you can send feedback to Knewton if you wish. You will not see an instructor cheat button, right? This is for instructors only. But you will see a more instruction button, which I highly recommend using if you're struggling. Click on this and it'll provide you with further reading, maybe some videos that are related to the objective of the question you're working on. And hopefully that helps you. Alright, so this first question is on the objective, determine the intercepts of a parabola given a function. Alright, so before I get into this question, I want to talk about the graph of a quadratic function. Right? Earlier in this intermediate algebra course, right, all these assignments have been geared toward an intermediate algebra course. We've seen linear functions, right? Functions whose graph, when you plot the ordered pairs of the function, they make a straight line. Well, now we're going to talk about the graphs of quadratic functions, right, where there's a variable squared. And the graphs of quadratic functions, when you plot those ordered pairs, will form a shape called a parabola. Right, so let me pull up some paper here. And let's talk about quadratic functions for a little bit before I get back into the assignment. Quadratic functions. Alright, so these are y equals, or f of x equals, some ax squared plus bx plus c. Ax squared plus bx plus c. Remember, x here is the input variable, y is the output variable. And if your output variable is equal to, a quadratic polynomial, right, this is a quadratic polynomial, then they call this, a quadratic function. And, a, b, and c are just real numbers, right? They're just coefficients. And of course, a can't be 0, because if a were 0, then it would be, no x squared, and then you'd have a linear function, right? Y equals bx plus c. So the coefficient of x squared can't be 0. Alright, so the graph, right, the graph of a quadratic function is called a parabola. Right. And a parabola, the parabolas we're going to see, where y is the output and x is the input, they're going to be either opening up, and they're like these U shapes that go up forever on both ends, or they could be opening down, and go down forever on both ends, right? But they're these U shapes that are very symmetrical. Right? And we'll talk about the axis of symmetry and stuff like that later. So a very simple example, the simplest example of a quadratic function would be y equals, x squared. Right, and I'll plot, I'll make a little chart here with x and y, and we can see some ordered pairs that belong to the function described by this equation. Well, obviously, if x were 0, y would be 0 squared, y would also be 0. If x were 1, y would be 1. If x were negative 1, y would also be 1. Right? Negative 1 squared is positive 1. If x were 2, right, y would be 4, which is 2 squared. If x were negative 2, y would also be 4. Right? Negative 2 squared is 4, and so on. 3, 9, negative 3, 9, and whatnot. And then if I plot these points, and I'll do my best little hand drawing here. Say this is the x, y coordinate plane, right? The x-axis is horizontal, y-axis is vertical. And I'll start plotting these points. All right. Well, the ordered pair is 0, 0. Right? That's the origin. That's here. That's on the graph. 1, 1. Right? 1 for x, 1 for y. That's this point here. But then negative 1, 1. Right? Negative 1 for x, positive 1 for y. That'd be here. And then positive 2 for x, positive 4 for y, right? So 2, 4, that's this point here. And, negative 2 for x, positive 4 for y again, so that's this point here. And what you're seeing is, again, and you could plot, you don't have to plug in just whole numbers. I could put in a half and get a quarter back. Right, 1/2 for x would be a quarter for y. Negative 1/2 for x would be a quarter for y. But all these points would form like this U shape. Right, that just increases, goes up forever on the right there, and also goes up forever on the left. And again, this is called a parabola. Right, a parabola. All right. Okay. Now the graph of, again, any function that looks like this, ax squared plus y equals ax squared plus bx plus c, is going to have either this shape where the u is opening up, or this shape where the parabola is opening down. And it's real easy to tell just by looking at the equation. Right? So some properties that we're going to come across. The first one is if we got y equals ax squared plus bx plus c, right? We're looking at functions like this. If a, right, if the coefficient of the x squared term, the quadratic term, if a is positive, then the parabola will be opening up. Then parabola opens upward. Alright, so like the one we just saw. Alright, like y equals x squared. the value of a, or the quadratic coefficient, is 1. It's positive, and you see the graph of this parabola is indeed, this one that's smiling, it's curving upward. If a is negative, right, if a is less than 0, that'll just flip it over. All right. Then the parabola will be opening downward. So like this, a little frown. Right, so if I were graphing y equals -1x squared, that would be this same parabola, just flipped downward. Instead of 1, 1, you'd have 1, -1. Instead of 2, 4, you'd have 2, -4. Right? It'd be the same parabola, just open downward. Right. Right. Now, every single one of these parabolas has something called a vertex, and also an axis of symmetry. So again, we have, for y equals ax squared plus bx plus c, right? We got to start off looking like this. If it doesn't look like this, we'll make it look like this. All right. If you have a quadratic function, all right, again, you got this, the graph is some parabola, either opening up or opening down, and it's very symmetrical. It's symmetrical about a vertical line, and I'll put a little dashed line here. And this vertical line is called, the axis of symmetry for the parabola. The axis of symmetry. Because if you were to fold along that line, the two halves would match up. The equation, right, for y equals ax squared plus bx plus c. The equation for the axis of symmetry is something I would just hopefully expect you to remember. Is the following. Now it's a vertical line. All right, for our parabolas in this assignment, it's going to be a vertical line that cuts the parabola into two equal halves here. And every vertical line is the equation, x equals some number, right? And what we're going to do is, the equation of the axis of symmetry for a quadratic function of this form, y equals ax squared plus bx plus c, is x equals the opposite of b divided by 2 times a, right, a little fraction. And I'll put this in a little bubble. Right, this is important. Axis of symmetry is x equals -b over 2a. Now again, it has to start like this. Right? The equation has to look in this form in order for me to jump to this conclusion that the vertical line that cuts it in half is this line here. Right, and then the final thing we're going to need to know is about, on this axis of symmetry, right, there should be a point. So again, for, say, f of x, I'm going to use f of x this time instead of y, and you'll see why in a second. For f of x, or y, equals a times x squared plus b times x plus c, right, you got the graph as a parabola, either opening up like this or opening down. Right, you got the axis of symmetry again. Right, I'll make a little dotted line in a different color. But then on the axis of symmetry, the axis of symmetry intersects the parabola at one point. And that point is either the lowest point or the highest point, right? If it's opening down like this, we're talking about the highest point of the graph. Right? And this lowest point or highest point, right? This point that the axis of symmetry has in common with the parabola, this is called the vertex of the parabola. And for an equation that looks like this, y equals ax squared plus bx plus c, or f of x equals ax squared plus bx plus c, any function of this form, the vertex is the point. It's an ordered pair. The x coordinate is just the, because it's on the axis of symmetry, this negative b over 2a is the x coordinate of this vertex, whatever that point is. And then the y coordinate is f of negative b over 2a. Right? So that's why I used function notation here to make this a little easier to write. Because you just take negative b over 2a, the x coordinate, and plug it in to the function and get your y coordinate, get your output. All right, so vertex at the highest or lowest point is this here. So again, you should really just remember, if I'm in this form, ax squared plus bx plus c, remember negative b over 2a. Now that'll be help you get the equation of the vertex, and then you plug that in, get the output, you get the coordinates of the vertex. All right, so lots of stuff here, lots of stuff. Now, what we're doing here, right, is not finding the axis of symmetry or the vertex or even graphing. I mean, it's part of the graph. We're asked to determine the intercepts. Now, I'm hoping you remember what intercepts are. Right? There were x-intercepts and y-intercepts for graphs. X-intercepts were points on the x-axis. And if you're on the x-axis, that means your y-coordinate is 0. And then y-intercepts were points on the y-axis. And if you're on the y-axis, the x-coordinates are 0. Alright, so I'm going to write out this function here, and then we'll try to find the intercepts, right, the x and y intercepts of this graph, if it has any, right? Because if the parabola is all above the x-axis, then there's no x-intercept. If it's all below the x-axis, then there's no x-intercept, right? So just be careful, right? The x-axis, remember the x-axis is a real number line. So if you try to find your x-intercepts and they're imaginary, if there's an imaginary number, that means the graph won't hit the x-axis, and we'll see all that in a second. Right. We'll probably see that with some examples here. Alright, so here's the quadratic function we're given. It's in the form I like, y equals ax squared plus bx plus c, where a is negative 3, b is negative 5, and c is positive 6. Now, before I get into the intercepts, here's how we're going to graph. Right? And this will come up in a later objective as well. Here's how I'm going to graph y equals ax squared plus bx plus c. And then I'm going to go to that graphing calculator website, desmos.com, and show you a better picture, because this is going to be by hand here. So the first thing I do is I find the axis of symmetry. And remember, that was x equals, it was a vertical line, x equals negative b over 2a. Alright, so for this one, that would be the opposite of negative 5 divided by 2 times negative 3. So that'd be positive 5 divided by negative 6, that'd be negative 5/6. X equals negative 5/6. Alright. Then I find the vertex. So we have the x-coordinate, right? Remember, this axis of symmetry also gives us the x-coordinate of the vertex. So now I just plug that in for x, right? X is negative 5, 6, so we get the y-coordinate. Y equals, negative 3 times negative 5 sixths squared minus 5 times negative 5 sixths, and then plus 6, and then I got a lot of fraction dealing with here. This would be negative 3 times, and then negative 5 sixths squared would be 25 36ths. And then we have negative 5 times negative 5 sixths would be positive 25 sixths. And then we have plus 6, and I need to get a common denominator. Now 3 goes into 36 12 times. All right, so this is actually negative 25 twelfths plus, and then 25 sixths I would multiply by 2 over 2 to get a denominator of 12 again. That's 50 twelfths. And then multiply the last 6 over 1 by 12 over 12 and get plus 72 twelfths. And we end up with the y-coordinate of the vertex would be negative 25 plus 50 is positive 25. 25 plus 72 would be 97 twelfths. Positive 97 twelfths. Okay. Which is a little more than 8. All right, this is 8 and 1/12. All right, 8 and 1/12. All right, because 80 is 96, 97 twelfths. Okay. So the vertex, that highest or lowest point, we'll determine that in a second, is the following point. X-coordinate, negative 5 sixths. Y-coordinate, 97 twelfths or 8 and 1/12. And then I'll plot this point. All right, so once I find the vertex, I will plot it. All right, so again, I'm doing the best hand drawing I can do. So remember, horizontal is the x-axis, vertical is the y-axis. And negative 5 6, let's say here's 0, and then let's say this is negative 1. Now negative 5 sixths would be like here. All right, this is going to be a hand drawing, it's not perfect. Negative 5 6 would be a little bit to the right of negative 1. And then I said 97 twelfths, right? That's 8 and 1/12. So 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, this is going to be bad. There's 8. Here's 8 and 1/12, 97 twelfths. So the point we're looking for the vertex is here. Negative 5 6, 97 twelfths to 0. All right. Now remember, the value of a is negative 3 here. Y equals ax squared plus bx plus c. So that means the parabola is going to be opening down. All right, the parabola is going to be opening down. So this parabola is going to be opening down, meaning it will have x-intercepts. If it were opening up, it wouldn't have x-intercepts. And that's the third part here. Let's find the intercepts. All right, I'm going to take my function here, And this is the part that we're asked to do for the question. All right, let's find the intercepts, if any. Right? Because sometimes you might not have. Oh, sorry, that should be on the screen. Find the intercepts, if any. All right, so let's start with the y-intercept. That's usually pretty easy. Remember, for y-intercept, you plug in x equals 0. All right, if you're on the y-axis, the x is 0. So then you got y equals, negative 3 times 0 squared minus 5 times 0. Basically, any term with x in it would disappear, and you'd have 6. Y equals 6. So the ordered pair is 0, 6. Right, there's the y-intercept. And I'll plot that. Right, there's 6 there. And you can use symmetry. You can use symmetry to find another point. But I'll make that my final step after finding the intercepts. All right, now for the x-intercepts. You let y be 0. Remember, if you're on the x-axis, the y-coordinate is 0. So that gives me a quadratic equation to solve. We have 0 equals negative 3x squared minus 5x plus 6. And I'm going to try solving this equation. Now I can use the quadratic formula. All right. Now me personally, when I'm solving an equation, quadratic, I don't like having a negative lead coefficient. So I'm going to multiply both sides by negative 1, right, times negative 1 here. And the left side would still be 0, and the right side would be 3x squared plus 5x minus 6. And now I'm using the quadratic formula. Right, it's in that standard form where everything's on one side, zero's on the other. So I can just state the solutions to this equation using the quadratic formula. X equals, the opposite of b, the linear coefficient, so negative 5 plus or minus the square root of b squared, right, 5 squared, minus 4 times a times c, 4 times 3 times negative 6. And all of this, right, divided by 2 times a, divided by 2 times 3. And so the solutions here, the x-intercepts, are negative 5 plus or minus. Now this is 25, and then, plus 72. Right, because 12 times 6 or 24 times 3, either way, and it's positive, so 25 plus 72 is 97, right? The square root of 97, all divided by 6. Right. So one of these x-intercepts has an x-coordinate of negative 5 plus the square root of 97 over 6. Right. So has an x-coordinate of negative 5 plus the square root of 97, all divided by 6, comma 0. Right, remember the y-coordinate is 0. And the other x-intercept would be negative 5 minus the square root of 97 divided by 6. Right, with the minus and then comma 0. Right, here are the two x-intercepts. So here's the y-intercept, right, 0, 6. And then here are the two x-intercepts. Now we are asked in the assignment, you can enter an exact answer, right? This would be considered exact, where you leave it the way it is without entering it into a calculator. But it also says you could round to 2 decimal places. All right, so I'm just going to do it on, I have a calculator. I'm just going to go off to the side. I'm just doing this off screen and entering, negative 5 plus the square root of 97. and then taking that value in parentheses and dividing by 6. So this first one here, or we could round to 2 decimal places. The x-intercept for the first one is about 0.81. It's 808, so 81, comma 0. And then this other one, right, doing -5 minus the square root of 97 over 6. I'm doing it on my calculator off screen. That x-intercept is approximately -2.474, so 47. Right, when I go to 2 decimal places, comma 0. All right, and I'm going to use these as my guide to, going back to my graph, back to the graph, right? Now this is going to be rough looking. So, yeah, let's say +1. Trying to keep, this might not be the greatest looking thing in the world. So, like, +1's there. One of the intercepts is at 0.81. That was -5 plus the square root of 97, all divided by 6. So let's say that's close to 1, 0.81, about there, right? So there's a point, right? X-intercept. And then the other one was at -2.47. So there's -1 on the x, -2 on the x, -3, and -2.47 is a little bit less than halfway. So let's say here, -2.47. There's the other x-intercept. All right, now let me show you my final step in graphing. All right, my final step in graphing is use the symmetry to plot points. And then complete the graph, right? Use the symmetry to plot points. Because if you write, let me draw in the axis of symmetry here. Remember, the axis of symmetry was x equals -5/6, right? Here it is. I'm going to do a little dashed line going up here through, x equals -5/6. Here's the axis of symmetry. I'm just going to write AOS for axis of symmetry. And the reason it's called that, the reason it's a line of symmetry is, look, if I go to a point to the right of the axis of symmetry, that's the same distance as a point on the left. So this distance here is the square root of 97 over 6. And so is this distance, the square root of 97 over 6. And then this point here, right, 0, 6. This is 5/6 to the right. So if I go another 5/6 to the left, -10/6, which would be -5/3, -1 2/3. So maybe about here, -5/3. There should be another point, -5/3, comma 6. All right, there's -5/3, comma 6 right there. But I'm just using the symmetry, right? The distance to a point on the right of the axis of symmetry should be the same as a distance to the point on the left. So that was 5/6 to the right, 5/6 to the left. And after you plot enough and you got the vertex and you got some points on either side, draw it in. All right, draw it in. So here it is. And don't make it pointy. Parabolas are not pointy. It's more curvy around the vertex. And coming down here through the axis of symmetry, through the x-intercept there, through the y-intercept here, down through the x-intercept here, and again it goes down forever, this parabola. So yeah, that was a lot, I know, but this is how I'm gonna go about graphing every single one of these. Again, we weren't asked to graph, we were just asked to find the intercepts, right? The y-intercept was 0, 6, and the x-intercepts, were either these with the exact answers or these when you round to 2 decimal places. Now let me show you on Desmos, all right, as well. Let me take this off. I'm going to go to that graphing calculator website, Desmos Parabola.com, the free online graphing calculator. And I'm going to enter this function that we were given, right? Y equals negative 3x squared minus 5x plus 6. And let's take a look at the key points. All right, let me zoom out a little bit here. Look at the point up here. Now, negative 0.833, that's negative 5.6. And 8.083, that's 8 1/12. That is the vertex. All right. And in fact, just to make sure you believe it, right, what was our vertex? So I'm going to put that point in. It was negative 5.6 for the x-coordinate, comma, and then 97/12 for the y-coordinate, and there it is. See that showing up on top of the parabola there? Okay. All right, and then look at this other key point, 0.6, definitely the y-intercept. And remember, we said the x-intercepts were at 0.81, 0, 0.808, 0.81, 0. That was the negative 5 plus the square root of 97 divided by 6, 0. And the other one was at negative 2.47, right? Negative 2.47. Now, it really should be negative 2. I mean, they rounded to 3 decimal places, but it's really negative 2.474. So if I'm running to 2 decimal places, it'd be negative 2.47. But there we go. All right, that was the negative 5 minus the square root of 97 all over 6, 0. All right. And let me put up the axis of symmetry as well. X equals, negative 5/6, and I'll make it a dashed line because it's not actually part of the parabola here. Let's make it a dotted line, and there you go. All right. See that green line? That's cutting through the middle of the parabola here, cutting through the vertex. X equals negative 5/6. That was that negative b over 2a. So it's a lot of stuff. I know it's a lot of stuff, and it took like 30 minutes to talk about this. But now that we've talked about it at least once, now that I brought everything up at least this one time, it's just going to keep coming back for the rest of the problems. All right. So back in the assignment, we're entering the x-intercepts. Now one of them was at, I'm going to do the 2 decimal places thing, so it takes less typing. 0.81, 0. Right. Then the other x-intercept was at negative 2.47, 0. Right. And the y-intercept was the ordered pair 0, 6. Right. We were asked to enter ordered pairs. Make sure you don't forget the commas. All right. Great. And after every question, right, there should be an answer explanation, whether you got it right or wrong. Please read this. Right. If you got it right, read through it just to make sure you got it right for the right reasons. Right. And if you got it wrong, read through it just to make sure you're learning from your mistakes. Try to figure out where you went wrong, why you were wrong, and figure out how to fix it in the future questions. All right, and you see they entered the exact x-intercepts at the end. I rounded it to 2 decimal places because they said we could, right? See, or round to 2 decimal places. All right, so let's continue on. All right, so that was a lot, I know, but it's going to keep. I'm going to do the same stuff every time. All right, so here again we're still working the same objective: determine the intercepts of a parabola given a function. All right, so we're given this quadratic function here, y equals, and it's in the form we like, right? Again, if it's not in that form, I'm going to put it in that form. Y equals ax squared plus bx plus c. And this time I'm just going to straight up find the intercepts, all right, and then punch them in. We can do graphs and whatnot, but I'm just going to go about finding the intercepts right from the get-go without graphing. All right, so we're given this, again, quadratic function. The graph will be a some parabola. And I'll go to Desmos after just so we can verify it, right? You should always be checking your solutions somehow. And we're asked to find the intercepts. Again, the easiest one's the y-intercept. All right, just replace x with 0, and you get y equals 20. So 0 for x, comma 20 for y. There's part of the answer, right? 0, 20. Now x-intercepts, these are the tougher ones, right? You got to put y as 0, right? Put in 0 for y if you're on the x-axis. So I got the equation 0 equals 2x squared plus 9x plus 20. And this is already set up the way I want if I want to use the quadratic formula. So I'm just going to jump right to it, use the quadratic formula. The solutions of this equation are x equals negative 9 plus or minus the square root of 9 squared minus 4 times 2 times 20, all divided by 2 times 2. So this is negative 9 plus or minus the square root. This is 81 minus 160. Right? This is negative 79 divided by 4. But yikes. Here I'm seeing the square root of a negative number. This is not a real number. It's imaginary. And remember, the x-axis is real numbers only. There are no imaginary numbers on the x-axis. So if your results, if your x-intercepts don't contain real numbers like this one does here, then that means the graph has no x-intercepts. Simple as that. Right? So if the expression inside the square root, when using the quadratic formula here, if that ends up being negative, right, you're taking the square root of a negative, that's imaginary, not real. And if it's not real, if your x-intercepts aren't real, then you have no x-intercepts, right? Because the x-axis is a real number line, not imaginary. All right, so back in the assignment, right, the y-intercept is easy, right? That's 0, 20. Right, we got that. The x-intercept, right? They said if there is no solution, right? If there's no intercept, just enter that empty set symbol, that circle with the slash through it, which, when I clicked on the box here, I'm seeing that right here. I just put the empty set symbol in the x-intercept parentheses just to indicate that the x-intercepts aren't there, right? The graph would not hit the x-axis. Now let's actually see that happening. Right? Let me go back to the Desmos website and let me show you. Let me punch in that function. All right, it was y equals 2x squared plus 9x plus 20. And let me zoom out of it until we see the parabola. Look, there's the parabola. And you see it's, got this vertex here, whatever this is. It's opening up, right? Remember the lead coefficient was positive. The quadratic coefficient was positive too, so it should be opening up. And look, it's all above the x-axis. There's no point on the graph of the parabola that will hit the x-axis, so therefore no x-intercepts. And you see the y-intercept of 0, 20. That's on it. We already saw that. Great. All right. So let me submit this answer here, and it should be good. All right, and please once again read through the answer explanations. All right, next question is on a different objective, but I've already done this with the first example. I am just going to do it again over and over again here. We're asked to determine the axis of symmetry, which is x equals that negative b over 2a if you're in the standard form, y equals ax squared plus bx plus c, and also find the vertex of the parabola. And once again, I'll put the graph on Desmos and show you that those are indeed, we'll check our answers, right? That we do indeed have the axis of symmetry and the vertex. All right, so again, it's in the form I want. So the axis of symmetry, again, I'm just going to abbreviate axis of symmetry, AOS, like this, is a vertical line. It's x equals, the opposite of b divided by 2a, where b is the linear coefficient, 4. So it's the opposite of 4, negative 4 in the numerator, divided by, and then 2 times a, where a is the quadratic coefficient, which is 1. And this is negative 4 divided by 2, that's negative 2. X equals negative 2. Alright, so you know what? I'm going to do a quick little hand drawing off to the side. You do not have to do this. Right? They're only asking us for the axis of symmetry and the vertex, but I'm also going to try drawing it because I know another objective is coming up where we have to draw these things. Alright, so x equals negative 2. So again, x-axis is horizontal, y-axis is vertical. Here's negative 1, here's negative 2, and I'm just going to make a dotted line, dotted vertical line at x equals negative 2. Like that. Alright, so there's the axis of symmetry. Alright, x equals negative 2. And the vertex is going to be on the axis of symmetry. Now the vertex, right, I've got the x coordinate, negative 2, when I found the axis of symmetry. Now I just plug that in for x, and we get the y coordinate. So y equals, negative 2 squared plus 4 times negative 2 plus 1. That's 4 minus 8 plus 1, that's negative 3. So the vertex is at negative 2 comma negative 3. Right. And I'll plot that. Now I know that's all they want. Alright, I'm actually done. I can go back and type these in, but I'm going to finish this off. Alright, I'm actually going to graph it. So negative 2 for x, negative 3 for y. This point here on the axis of symmetry is the vertex. Alright, and then the graph. Now you can find all the intercepts. It's going to open up, right? The lead coefficient is positive, positive 1. So this is the vertex. It's going to open up, and it will hit the x-axis. Alright, but the easy one is the y-intercept, right? The y-intercept would be 0, 1, right? If x were 0, y would be 1. Right, there's the point 0, 1. Now think about the symmetry. This point, 0, 1, is 2 units to the right of the axis of symmetry. So that means 2 units to the left of it, which would be at negative 4, will also have an output of 1. Alright, there's the point negative 4 comma 1. And you could test it out. Plug in negative 4 for x. You'd have 16 plus negative 16 is 0 plus 1 is 1. The output would be 1. So that's what I meant by use symmetry earlier. If you know there's a point 2 units to the right, then there's going to be a point 2 units to the left. And seriously, once you have the vertex and a point on either side, and you know it's a quadratic, you know it's a parabola, you can draw a rough sketch of it. There's going through that y-intercept, and then over here going through the point negative 4, 1. And there's a very, very rough sketch of the parabola represented by y equals x squared plus 4x plus 1. Now again, I know I said let's find the x-intercepts. You can see there's x-intercepts here. The points, there are points on the x-axis. But since I'm not asked to do that specifically here, I'm not going to. I just wanted to draw a rough sketch. And let me also show you on Desmos a better sketch of this parabola. So again, let me punch in the function they gave us. Y equals x squared plus 4x plus 1. And look, see the vertex is at negative 2, negative 3. There's x-intercepts. They're at negative 0.268. That's not the exact value. Those are rounded. Negative 3.72. And 0, 1. And then here's negative 4, 1. Right, up, I had it. Alright, whatever. Let me just put in the point negative 4, 1 just to show you that it's on it. Right, negative 4, comma 1. And there it is, right? 2 units to the right, 2 units to the left of the axis of symmetry. And you could put in the axis of symmetry as well. Alright, x equals negative 2. And I'll just make it a dashed line, a dotted line, because it's not actually part of the parabola. Right. And again, you can see the symmetry around this line, around this vertical line, x equals negative 2. Alright, but back in the assignment, the axis of symmetry, x equals negative 2, right? Just a number for the axis of symmetry there. And then the vertex is a point, has an x coordinate of negative 2, right, which was the same as the number you'll put in for the axis of symmetry. And then when I plug negative 2 in for x, the output was negative 3. Right, the ordered pair negative 2, comma negative 3 for the vertex. What happened there? Negative 4 over 2. Oh my goodness. Oh my goodness. Well, here's a first in a while, a mistake. And here's your lesson here. Read more carefully. My apologies. It says find the axis of symmetry and vertex for a parabola y equals x squared plus 4x minus 1. I had plus 1, didn't I? Yeah, I mean the axis of symmetry is still correct because the b and the a didn't change, right? B is still 4, a is still 1, so negative b over 2a doesn't change. Oh my goodness. Alright, so back on my paper, I am so sorry. This was supposed to be minus 1. And then this would be minus 1, minus 1. And then the output would be minus 5. Alright. And then this is all bad too. But so the axis of symmetry is x equals negative 2. And the vertex is negative 2, comma negative 5. Oh no. Alright, so let me re-enter that. Negative 2, negative 5. And submit. And hooray. Yeah, mistakes can help us grow. Indeed. Yeah, okay, so the lesson here is read more carefully. My apologies. Alright, so that might actually throw one more question here. So, hey, we'll get some more practice out of this. Alright. So once again, I see I didn't really make any progress on that objective. Actually, I did. Okay, well, here we go. Give it another one. Now let me actually copy this down correctly, and I'll come back and we'll find the axis of symmetry and the vertex. Alright, this time I actually copied it down correctly. I double checked. Y equals negative x squared minus 8x plus 8. And you were probably screaming at me the whole time with the last one, if you noticed I copied it wrong. Anyway, mistakes happen. Alright, so again, it's in the nice form that I like, y equals ax squared plus bx plus c, where a is negative 1, b is negative 8, c is positive 8. Alright, so the axis of symmetry is, a vertical line, x equals, and it's, the negative b over 2a, the opposite of negative 8, all divided by 2a, 2 times negative 1. So this is negative 4. Alright, 8 divided by negative 2. Alright, so x equals negative 4 is one thing I'll enter for the axis of symmetry. And once again, you don't have to do this, but I'm going to. Here's the xy plane, and x equals negative 4. Alright, so negative 4 on the x-axis there, and I'll draw a little dotted line, a vertical line. Alright, there's the axis of symmetry for this parabola, and the vertex, right, will show up on this line. And that's the other thing we're asked to find, right, the vertex. Now I know the x-coordinate is negative 4. I just need to plug that in and find the y-coordinate. So we have the opposite of, negative 4 squared minus 8 times negative 4, then plus 8. So this is negative, 16 plus 32, which would be positive 16, plus 8, which would be 24. All right, so the vertex is negative 4, comma 24. All right. So let's just say that's up here. All right, 24 on the y-axis. So if our plotting points, there's the vertex. And again, the lead coefficient is negative, so this is going to open down, meaning that the parabola will hit the x-axis. It will have x-intercepts if you want to find them. But again, I think the easiest one to find would be the y-intercept would be at 0, 8. So if that's 24, let's go a third of that. Say that's 8. And 0, 8 would be on this parabola. Right, there's 0, 8. And then if you use some symmetry, the point 0, 8, that's 4 units to the right of the axis of symmetry. So then if I go 4 units to the left, you get another point, negative 8, 8. And you can check it out. Plug in negative 8 for x, and you'd get 8 for y. I promise you. And then it's this parabola, opening down. Again, the vertex here should be the highest point on the graph. And it will hit the x-axis. It will have x-intercepts, but I don't want to find them right now. I'm not asked to. All right, once again, let's take a look at the graph on the Desmos site. All right. Let's look at the graph on the Desmos site. We have the function y equals negative, x squared minus 8x plus 8. And look, there's the parabola, and again the vertex way up here, the point negative 4, 24, like I said, right? And I said 0, 8 was the y-intercept, right? And over here, you should have negative 8, 8, right? Using the symmetry. That's the other point I found when I wanted to graph the thing. All right, but we're not asked for all that, right? We're just asked for the axis of symmetry was x equals, negative 4. That was that negative b over 2a. That's also the x-coordinate of the vertex, and then the y-coordinate was positive 24. Right? And that's all they want from us. Wonderful. All right, great, got it right the first shot because I actually paid attention to my signs and wrote down the problem correctly. Please do that. And also read the answer explanations when you're done. All right, next question. All right, so now we're on the objective we haven't seen yet, but I've been doing it. All right, I have been doing it, graphing a quadratic function by plotting points and determining the direction a parabola opens. So he says here, graph the parabola y equals x squared plus 3 by plotting any 3 points on the parabola. Right. Move the key points on the graph to create the parabola. You have these points here that you get to move around, right? And you can move them anywhere. So you don't even need to know the vertex or axis of symmetry. You're just asked to plot any 3 points and move these points to those 3 locations. Very, very simple. All right, so I'll write out the function. Okay, so I'm going to actually do the thing I've been doing though with the axis of symmetry and just finding some other points. Now be careful here, right? This particular quadratic function is ax squared plus bx plus c, but it's x squared plus 0x plus 3, right? So a is 1, b is 0, and c is 3. Right? Sometimes people make the mistake of just thinking the second number they see is the b, but that's not true. Right? It's the coefficient of x, which in this case is 0. So x equals, negative b over 2a, which would just be 0. Right? You have 0 divided by 2. So the axis of symmetry is the y-axis. Right, here's x equals 0. Right, x equals 0. The y-axis is the axis of symmetry. Then the vertex is 0, 3, which is also the y-intercept. So that stinks a little bit, because that means I need to find some other points. Now, again, they didn't care for any intercepts or anything like that. They just wanted to find 3 points. So 0, 3 is one of them. That's the vertex. It's going to be opening up, right? Remember, the lead coefficient here is positive, so it's going to be opening up. That means there aren't any x-intercepts. The graph will not hit the x-axis. So I'm just going to plug in some other value, say 1. So just other points. Right? All I need are 2 other points. When x is 1, y would clearly be 4. So there's 1, 4. And then I can use the symmetry. This point 1, 4 is 1 unit to the right of the axis of symmetry. So that means 1 unit to the left at -1 would also have an output of 4. Right, there's a point over there. And you could also just plug it in, And here it is, right? The graph should look like this. Something like this. Right? Again, it's a hand drawing, but going back to the assignment, I'm just going to plot these 3 points. All right, just move my points here. Right, one of them is at 0, 3, 0, 2, 0, 3, and then one of them at 1, 4, and the other one at -1, 4. There, and there's the parabola that was opening up like I had in my hand drawing. Great. So yeah, real simple these. You should just have to move 3 points around to 3 actual points that satisfy the equation. They did theirs here. They did a little chart, whatever. Right? Any 3 points on the parabola will work. All right, next question. So yeah, same thing. We're asked to graph a quadratic function by plotting points here, and it said y equals x squared minus 2 by plotting any 3 points, and hopefully it's obvious that 0, -2 would be the intercept, and then if I plug in 1, I'd get -1. So 1, -1, and then if I plug in -1, I'd also get -1. There you go. 0, -2 for the vertex, 1, -1, and -1, -1. You could also find the intercepts, but those are, these points are only allowed to move by 1s. So, the intercepts would be square root of 2 and negative square root of 2. And you see that, the graph of the parabola is hitting the x-axis, and that would be at the square root of 2 and negative square root of 2, but, can't move the points there. I have to move them on, like, a whole number of spots. So, pretty simple. Just moving some points around to actual points, ordered pairs that satisfy the equation. And once again, please, read through the answer explanations. All right, next question. Another graph. All right, this one's pretty simple again when it eventually comes up. Yeah, it looks like negative x squared plus 2. Y equals negative, the opposite of x squared plus 2. So 0, 2 would be on this. That would actually be the vertex. And then, 1, 1 would be on it, right? -1 plus 2. 1, 1. And same with negative 1. Negative 1 plugged in for x, you'd have, negative 1 squared is 1, times negative 1 is negative 1, plus 2 is 1. Negative 1, 1 as well. And then you could also use the symmetry. Right, the y-axis would again be the axis of symmetry, and these points are symmetrical, both 1 unit away from the axis of symmetry on either side. Yeah, these should be the easiest questions, I think, in all this assignment. And again, please, read through the answer explanations. All right, got one more of these. Looks like it's just y equals negative x squared minus 4. Now, if they give you any more complicated stuff, again, just find 3 points. Just find 3 ordered pairs and move these points around to them. So once again, there's no x term. So the y-axis is the axis of symmetry, and the vertex would be 0, negative 4. Right, 0, negative 4, and then when I plug in, the intercepts would be at 2, 0, and negative 2, 0. Right? Well, actually, no, it's opening down. It's opening down. So there are, there's the vertex, 0, negative 4, and then it opens down, right? The lead coefficient's negative. So there aren't any x-intercepts. All right, so I'm just going to plug in 1 and negative 1 again. If I plug in 1, I get negative 5, and then using symmetry, get negative 1, negative 5 as well. Right? And there we go. That should be that parabola. Hooray. Alright, so that objective's done. That should be a real quick one. Right? Just finding 3 ordered pairs that would belong to the parabola and moving the points around to them. Alright. So now we're going back to some other objectives, either finding intercepts or finding axis of symmetry and vertices. So we're back to this determine the intercepts. Alright, so this time, again, I'm not going to graph it anymore. I'm just going to write this equation out, write this function out, and we'll find the intercepts by plugging in 0 for x or 0 for y and solving. Right, so the function we're given, and again I copied it down correctly, I double checked. Y equals negative 2x squared minus 5x plus 1. Let's start with the easy one, the y-intercept. Just replace x with 0, and you get y equals 1. Right, so the ordered pair is 0, 1. Right, there's part of the answer. Right, 0, 1 would be on the graph of this, the y-intercept. Right, then the x-intercepts, if it has any, you're going to replace y with 0 and see if there are real number solutions for x. So you have 0 equals negative 2x squared minus 5x plus 1. And again, with equations, quadratic equations, I like having a positive lead coefficient. So I'm going to multiply both sides by negative 1 here, times negative 1, and we get 0 equals 2x squared plus 5x minus 1. And then we can jump to the quadratic formula. All right, so the solutions of this equation are negative 5 plus or minus the square root of 5 squared, so 25, minus 4 times a times c. Now 4 times a times c is negative 8. Minus that would be plus 8. So that's a positive number. All right, that's a positive number. So we're good. And then divided by 2 times a, which is 4. So we have negative 5, plus or minus the square root of 33 all over 4. So the x-intercepts are the following. One of them is negative 5 plus the square root of 33, all divided by 4, comma 0. And the other x-intercept would be negative 5 minus the square root of 33 divided by 4, comma 0. Now it said we could enter exact answers or round to 2 decimal places. And I'm going to do that actually. So off on a calculator, just off screen, I'm putting in negative 5 plus the square root of 33, and then that all divided by 4. So this one intercept is approximately 0. Now it says 186, so it'd be 0.19 if I go to the nearest hundredth, round to 2 decimal places. So 0.19 comma 0. And the other one, when I put in, negative 5 minus the square root of 33, all divided by 4, that's approximately negative 2 point, and then it's 686, so 69 when rounding to the nearest hundredth. All right, so here's what I'm going to enter for those. Right, again, you can enter the exact values without calculator work, or punch it in a calculator and round to 2 decimal places. They said either are acceptable. All right, so for the x-intercepts, one of those was 0.19, comma 0. Don't forget the comma. And the other x-intercept at approximately negative 2.69, comma 0. And then the y-intercept at 0, comma 1. Right? 0 for x, 1 for y. Great. All right, and once again, please read through the answer explanations. All right, see if they entered the exact answers. I entered rounded ones. Either way is fine. All right, up next, there's one more question here related to the intercepts. So again, I'll copy this function down and we'll find them, the y-intercept and the x-intercepts, if there are any. All right, so once again, make sure you copy the problem down correctly. All right, like I didn't do that one time. Y equals x squared plus 4x minus 6. The y-intercept is clearly 0, negative 6, right? If x were 0, y would have to be negative 6, right? So that's part of the answer, the y-intercept. Then the x-intercepts, I'm solving this equation. I put in 0 for y. We get 0 equals, x squared plus 4x minus 6. This one I'm going to solve completing the square. You can use the quadratic formula, but this would be x squared plus 4x equals 6, adding 6, and then I would complete the square by adding 4 to both sides. And this is x plus 2 squared equals 10. So x plus 2 equals plus or minus the square root of 10, which is not imaginary. So I do have some solutions here that are real. There are x-intercepts, so negative 2 plus or minus the square root of 10. All right, so one of the x-intercepts is negative 2 plus the square root of 10, comma 0. And the other x-intercept is negative 2 minus the square root of 10, comma 0. And there you go, right? And remember, if you ever take the square root of a negative with these, and you end up with imaginaries, then the graph won't have x-intercepts, and we saw that before. And I'm going to actually enter the exact value this time. Why not? All right, so one of the x-intercepts is negative 2 plus the square root of 10, comma 0. The other is negative 2 minus the square root of 10, comma 0, and then the y-intercept is 0, comma negative 6. And those those should be good. Great. All right, so that objective's done now, right? Finding all the intercepts, the way you would find intercepts for any function, not just quadratic functions. Right? Plug in 0 for x for the y-intercepts, and plug in 0 for y to find the x-intercepts. All right, then the final questions should be on, determining the axis of symmetry and the vertex of a given quadratic function. And once again, they're giving us a quadratic function that's very nice, in that form, y equals ax squared plus bx plus c. So I should be able to jump straight away to the vertex and axis of symmetry. All right. And again, I'll draw it by hand as well and show you on Desmos just to double check things. But make sure you write out the question correctly first. Alright, so we're given y equals negative 4x squared minus 32x minus 10. The axis of symmetry is a vertical line, right? X equals, and it was that, the opposite of b, so the opposite of negative 32 divided by 2a, divided by 2 times negative 4. So this would be 32, divided by negative 8, that'd be negative 4. Right? So x equals negative 4 is our axis of symmetry, and I'll draw this. Just a rough hand sketch here. So there's x equals negative 4, and I'll draw that little dotted vertical line. And there's the axis of symmetry. And the vertex will be on this, right? Now the vertex, right, I have the x coordinate is negative 4. I know that much. Now I just plug it in and find y, the y coordinate. So y equals, negative 4 times negative 4 squared minus 32 times negative 4, and then minus 10. So this is negative 64, 16 times negative 4, and then plus 128, negative times negative, and then minus 10. That's positive 64 minus 10, that's positive 54. All right, so the vertex is at the point negative 4, comma, positive 54. So that'd be up here somewhere. Right. Plot that point. And the parabola would be opening down. Right, it's got a negative lead coefficient, so there would be x-intercepts, right, if I were asked to find them. Now the y-intercept would be at 0, negative 10. Right, the y-intercept would be at 0, negative 10, so down here. And using symmetry, another point on this graph would be at negative 8, negative 10. Right? Because this point's 4 units to the right of the axis of symmetry, so there should be a point on the parabola that's 4 units to the left. And then making a very, very rough sketch. And again, don't make it pointy, make it curvy at the vertex. Something like this. This is very, very rough. Right. But let's go to the Desmos site. Right? And I'll enter this function that we were given. Y equals negative 4x squared minus 32x minus 10. And look at the going up here, right? You see that, oh, come on. All right. There's negative 4 comma 54, right? Then scrolling down, you see the y-intercept at 0, negative 10, right? And there should also be this point, negative 8, negative 10, which I said was also on it. All right. But yeah, we didn't have to do all that though. We just had to enter the axis of symmetry, x equals negative 4, and then the vertex has, that same x coordinate, negative 4, and the y coordinate of 54. And that's all we were asked for. All right. Again, please read through the answer explanations. Okay, hopefully I got just the one more. I mean, I did get the one wrong earlier because of the error I made writing the problem down. We'll see if this is the last one. Looks like it might be. So I'm going to do it again. Now this time I'm not going to graph, right? This is the last one probably, so I'm just going to write it out and we'll state what the axis of symmetry and the vertex are and be done with it. Alright, so it's in the form I want, right? Y equals ax squared plus bx plus c, great. Once it's in that form, I can jump right to what the axis of symmetry is going to be. And it's a vertical line, right? X equals some number. That was the opposite of b over 2a, so negative 12 over 2 times negative 2. Right? B is 12, a is negative 2. That's negative 12 divided by negative 4, that's positive 3. Right, so there's the first part. And then the vertex will be on this line. Right? The vertex is a point where the x coordinate is 3. And I just plug in 3 for x and find the y coordinate. Y equals, negative 2 times 3 squared plus 12 times 3, then plus 9. This is negative 2 times 9, that's negative 18, plus 12 times 3 is 36, and then plus 9. Negative 18 plus 36 is positive 18, plus 9 is 27. So the vertex is the point 3, comma 27. And again, you can plot this and then find a point on either side of the axis of symmetry and then draw a rough sketch if you wish. But I'm not going to do that for this last one. So yeah, so all I'm entering are x equals 3 for the axis of symmetry. Vertex is the point 3, comma 27, and that should be good. Wonderful. All right, and it looks like that completed it. All right, so even though I got that one wrong, it gave me a second chance. I got it right, and it counted as if I got it right on the first time. Wonderful. All right, and that should be it for this assignment, right? This version of this assignment. And as I say at the top of these videos, right, please understand that the questions I saw here are not necessarily going to be the same questions you see when you work on the assignment on your own. But the objectives are the same, the kinds of questions are the same, how you would work on them should be similar. So I'm hoping that watching me go over these 12 questions in this video help you in some way when you're working on the assignment on your own later. And thank you very much for watching.